Bingalaba, and welcome to the second part of our Unit 6 presentation on the surrogate keys and higher-level normal forms of database tables for CIS 3107 database modeling. We'll be covering section 6.4 through 6.5 in our text. In this second presentation, we will learn ways to improve our database design, about surrogate key considerations, and the normal forms BCNF and 4NNF. Now that the table structures have been cleared up to eliminate the troublesome partial and transitive dependencies, we can focus on improving the database's ability to provide information and on enhancing its operational characteristics. Database designs are improved by evaluating the PK assignments, naming conventions, and attribute atomicity. An atomic attribute is an attribute that cannot be further subdivided. We will also need to identify any new attributes and relationships as well as refine primary keys as required for data granularity, which is the level of detail represented by the values stored in a table's rows. Finally, improving design means maintaining historical accuracy and evaluating the use of derived attributes. We will notice a few enhancements in Figure 6.6. By evaluating PK assignments each time a new employee is entered into the employee table, a job_class value must be entered, which causes issues if there are data entry errors. Therefore, it would be better to add a job_code attribute to create a unique identifier to be a primary key as well as a surrogate key. Since surrogate keys are usually numeric, they are often generated automatically by the DBMS and are therefore free of special meaning, and they are usually hidden from the end users. By evaluating naming conventions, the CHG_hour was changed to job_CHG_hour to indicate its association with the job table. In addition, the attribute named job_class does not quite describe entries, so the label job_description fits the entries better. Let us identify new relationships. Since users need to track which employee is acting as the manager of each project, a new relationship between employee and project will allow the database to supply detailed information about each project manager is issued by using the employee_num as a foreign key in project. When we are refining attribute atomicity, clearly the use of the emp_name in the employee table is not atomic because emp_name can be decomposed into a last name, a first name, and an initial. Let us look to identify new attributes as well. If the employee table were used in a real-world environment, several other attributes would have to be added, such as an employee hire date attribute or emp_hire date. To refine primary keys as required for data granularity, the assignment table in 3NF uses the assign_hours attribute to represent the hours worked by a given employee on a given project. But those values may represent the hourly total, daily total, weekly total, monthly total, or yearly total. Clearly, assign_hours requires more careful definition. That primary key is useful in representing only the total number of hours an employee worked on a project since its start. Using a surrogate key, such as assign_num, provides lower granularity and yields greater flexibility. To maintain historical accuracy writing, the job charge per hour into the assignment table is crucial to maintain the historical accuracy of the table's data. It would be appropriate to name this attribute assign_change_hour. We can also evaluate the use derived attributes. The derived attribute named assigned_charge is the result of multiplying assign_hours by assign_charge_hour. This creates a transitive dependency such that assign_charge times assign_hours yields assign_charge_hour. If the calculation is done at the time of the data entry, it will be completed when the end user presses the enter key, thus speeding up the process. Over time, a composite primary key might become too cumbersome to use as the number of attributes grow. and the search routines become too difficult to write. As discussed in the previous unit, when the primary key is considered to be unsuitable, designers use surrogate keys. At the implementation level, a surrogate key is a system-defined attribute generally created and managed via the DBMS. Usually, a system-defined surrogate key is numeric, and its value is automatically incremented for each new row. Tables in 3NF will perform suitably in business transactional databases. However, higher normal forms are sometimes useful. A table is in Boyce-Codd normal form, BCNF, when every determinant in the table is a candidate key. Recall from Unit 3 that the candidate key has the same characteristics as a primary key, but for some reason it is not chosen to be the primary key. Clearly, when a table contains only one candidate key, the 3NF and the BCNF are equivalent. In other words, BCNF can be violated only when the table contains more than one candidate key. The table structure shown in Figure 6.8 has no partial dependencies, nor does it contain transitive dependencies. The condition C depends on B indicates that one key attribute determines part of the primary key, and that dependency is not transitive or partial because the dependent is a prime attribute. Thus, the table structure meets the 3NF requirements, although the condition C determines B causes the table to fail to meet the BCNF requirements. To convert the table structure in the previous Figure 6.8 into table structures that are in 3NF and in BCNF, first change the primary key to A plus C. This change is appropriate because the dependency of C determines B means that C is effectively a superset of B. At this point, the table is in 1NF because it contains a partial dependency, C determines B. Next, follow the standard composition procedures to produce the results shown in Figure 6.9. You might encounter poorly designed databases, or you might be asked to convert spreadsheets into a database format in which multiple multi-valued attributes exist. A table is in fourth normal form, 4NF, when it is in 3NF and has no multi-valued dependencies. If you follow the proper design procedures illustrated in this course, you should not encounter these issues. The discussion of 4NF is largely academic if you make sure that your tables conform to the following two rules. 1. All attributes must be dependent on the primary key, but they must be independent of each other. 2. No row may contain two or more multi-valued facts about an entity. Figure 6.11 illustrates how a set of facts can be recorded in very different ways. The attributes org_code and assign_number each may have many different values. In normalization terminology, this situation is referred to as a multi-valued dependency, which occurs when one key determines multiple values of two other attributes, and those attributes are independent of each other. The presence of a multi-valued dependency means that if table versions 1 and 2 are implemented, the tables are likely to contain quite a few null values. Version 3 at least has a PK, but it is composed of all the attributes in the table. In fact, version 3 meets 3NF requirements, yet it contains many redundancies that are clearly undesirable. The solution is to eliminate the problems caused by the multi-valued dependency. You do this by creating new tables for the components of the multi-valued dependency. In this example, the multi-valued dependency is resolved and eliminated by creating the assign and the service_v1 tables depicted in Figure 6.12. Those tables are said to be 4NF. In summary, almost all business designs are in 3NF as the ideal normal form. A special, more restricted 3NF, known as Boyce-Codd normal form, or BCNF, is also used. A table is in 3NF when it is in 2NF and contains no transitive dependencies. Given that definition, the Boyce-Codd normal form, BCNF, is merely a special 3NF case in which all determinant keys are candidate keys. When a table has only a single candidate key, a 3NF table is automatically in BCNF. A table in 3NF might contain multi-valued dependencies that produce either numerous null values or redundant data. Therefore, it might be necessary to convert a 3NF table to the fourth normal form, 4NF, by splitting the table to remove the multi-valued dependencies. Thus, a table is in 4NF when it is in 3NF and contains no multi-valued dependencies. Thank you for viewing our Unit 6 Part 2 presentation. The diagrams and content of this lecture were derived from our textbook. For more detailed treatment of these concepts, please review pages 215 to 226 in our text.